Hello, everyone, and welcome to today's event. Today, our speaker is Mary Hu. She's a senior data scientist at Microsoft. Mary Hu is a data science lead for Windows Experimentation platform at Microsoft. She has been working as a data scientist on the Connected Service and Experiences data team for 5 years, with a primary focus on running randomized control trails for various types of features in the operating system to ensure end users have a good experience with Windows. Mary, I'll hand it over to you now.
Thank you for the introduction. Hello, everyone. Welcome to our session today. My name is Mary. I'm a data scientist working on the Windows Experimentation platform. And today I'm going to talk about the A/B testing on client and on server side. So to motivate some about this topic, let's look at the life of a great idea. This is a true Bing story a couple years ago. An idea was proposed in early 2012 to change the way ad titles were displayed on Bing to make them longer. So the one you see on the left was the control group, which was what it was like back then. And the one you see on the right side is the treatment group, which is the new idea. So you see the title becomes longer. So what happened to that idea? Actually, in Bing team, everyone's super creative. People come up with great ideas all the time. It becomes one of the hundreds of ideas proposed. And it seems not so much interested, and not everyone was willing to invest time into it. And therefore, the implementation was delayed, and it was just left on the table. Soon after that, an engineer actually thought this is not a difficult thing to implement. So he spent some of his personal time and implemented the idea. And then he started a controlled experiment, aka A/B testing. As he started the experiment, an alert fired that something is wrong with revenue, as Bing was making way too much money. Such alerts are very useful to detect bugs, like when you are logging revenue data twice or you're having some significant data pipelining issues. So the team went all in to debug what's going on with the revenue data. And it turns out that actually there was nothing wrong. The idea itself, just by making the title longer, actually increased the Bing revenue by 12%. And at that time, it was over 120 million US dollars without hurting any guardrail metrics, meaning our customers' experience was not hurt at all. What does that tell us? It tells us that we're actually terrible at assessing the value of ideas. In fact, if we look at all the historical experiments that we run at Microsoft, 1/3 of them are actually positive ideas and improved something. 1/3 of them were flat. Another 1/3 of them were actually negative, meaning they regressed something. And all of them were with statistical significance. So, in companies like Microsoft, Google, or any other companies, we work with smart people all the time, and everyone has brilliant ideas that they think can make the products better. However, as a centralized experimentation team, or as a data scientist who works on an experimentation platform, a lot of the times our job is actually to tell people that their new, beautiful, brilliant baby is actually ugly. It is a depressing message to convey, but sometimes it's just our job. So for today's talk, I'm going to talk about the importance of A/B testing, some basic concepts of it, example of experiments, common pitfalls, and finally draw some conclusions. With that, let's dive right into the importance of A/B test. In statistical world, we all know that correlation is not causation, and it's very hard to draw causation. For example, you observe the churn rates for users using or not using your feature, and churn rate is for users who stop using the product 30 days or later. As you observe the data, you find that 25% of the new users that do not use your feature actually churn, and 10% of the new users that use your feature churn. Does that mean that your feature reduces churn rate and thus is critical for retention? Of course not. What's wrong here? The flaw is that the relationship between the feature and retention is actually correlational and it's not causation. Another example comes to the Office 365 churn analysis. We realize that users who see error messages in Office 365 actually churn less. Does that mean we want to show our customers more error messages to help them retention? Of course not. It just means that those customers happen to be the heavy users as well. The heavy users use the feature more, and they happen to see the error messages more, and there are also higher retention rates. So in this paper, there were more examples of common analysis flaw that you can check out. Another example for observation is that palm size correlates with your life expectancy. The larger your palm is, the less you will live on average. Try it out. Look at yourselves and think about your friends or your family members, or look at your family members and see who is expected to live longer. But please do not try to bandage your hands, as there is a common cause. Women have smaller palms and live 6 years longer on average. So the reason why the larger your palm is, the less you will live, is very much correlated with the gender here instead of the palm size. So here we know that A/B test is the best scientific way to prove causation. Because when you balance all the confounding variables between control and treatment group and everything else cancels out, the only differences you see in the measure movements is because of the feature itself, which is the treatment that you introduced. How about measure user behavior before and after ship? Would that also help? So a couple years ago, Amazon was testing the different website. Let's call the original website being website A and the new website being B. And if we look at this data across time, then we see after October 28th, the website B behaves really well. But does that mean that website B helps drive up Amazon Kindle sales? The flaw here is that this approach misses time-related factors, such as external events, weekend, holidays, any seasonality-related stuff. So what's really happened here is that on October 28th, Oprah called Kindle her new favorite baby, and that was the reason why the sales was driven so hard. And in fact, Amazon did run an experiment on these two websites, and holistically, website B always performed worse than website A. So in a nutshell, how does A/B test work? It's a very simple concept. You have 100% of the users, you randomly split them into half and half, 50% in control group, which is basically usually the existing system, and another 50% in the treatment group, which is the new feature that you're proposing. You collect metrics from both of them and you analyze the results. Here, the really key part is the randomization at the first step. You really want to make sure that the users in control and treatment group are truly randomized, meaning all the attributes are the same across them. And this is to ensure the causation instead of just correlational studies. And A/B test is just the simplest version of the controlled experiments. Instead of doing A/B, you can have A/B/C/D, meaning you can have multiple treatments, more than one treatments. And also A/B test has multiple different names across the industry, depending on which company you're talking about. Microsoft calls it flights, Google calls it 1% tests, and some other companies call it all different ways. But on the basic of it, it's just this A/B testing concept. And of course, once you collect all the data and doing the analysis of the metrics, you need to run statistical tests to confirm the differences are not due to just noise. So with that, let's jump right into some statistical foundations. Let's go back to the basics. In an A/B testing scenario, you're trying to compare two different things. Let's say in this scenario, you're trying to compare the button on the left, which is the blue Start Now button, and the button on the right, which is the green Start Now button. And you want to know which button is better, A or B. How can we establish which variant is better? In an ideal world, we would want to create two universes, and the two universes are completely the same. In the first universe, we show all people variant A. In the second universe, we show all people variant B. And then we collect data from them and measure on the metrics that we care about, do the comparisons, run the statistical tests, and see which one performs better. This would ensure that any difference we observe was caused by the treatment itself and not by any other noises, because these two universes are completely identical. However, it's probably pretty hard, if not impossible, to create alternative universe. So instead, we would randomly split our user base such that some percentage of the users would experience variance A, and the other some percentage would experience variant B. Usually we do it 50-50, but you can do it in any percentage distribution. At the end of the experiment, we would measure the difference between the two groups, run statistical tests on them, and then understand which one performs better. The null hypothesis is that there is no treatment effect. In other words, it means that any difference between the control and treatment group is actually caused by the noise. And here we have the very famous p-value concept, which is the function of the observed sample results relative to a statistical model, which measures how extreme the observation is. And usually we set the p-value threshold to be 0.05. And now, of course, we'd have a lot of problems with false positives, and that we need to create some more creative ways, different methodologies or advanced tools to help our customers understand when it is actually a true a false positive, when it's a true positive. And with that, let's talk about the experiments on the client. So all the previous example I gave are examples on the server side, on the Bing website, Amazon website, Amazon website, all the different websites. And in websites and in webs and in apps, it's usually pretty clear for people how experimentation works and why we need experiments. However, on the client, in the operating system, why do we even need experiments? We have been shipping features to the operating system just by doing lab testing in the past few decades. So why do we need to run experiments now? Why is the traditional approach of extensive testing not sufficient anymore? Here I can give you at least 5 reasons. The first reason is that there were just way too many combinations of different types of softwares, hardwares, and user scenarios. Just think about the types of devices you have in your family, in your household. How many different types of devices you have? Laptops, desktops, phones, and some are connected to Wi-Fi, some are just LTE. It's all different. And how can we capture all those different combinations in a lab? It becomes impractical. For example, there was this experiment called the Host Activity Manager. It is a lifetime manager that's used to replace the old one for managing the life cycle for universal apps in the Windows operating system. So we need to abstract away the differences in hardwares, the foundation of all the different types of apps. And also, users may use different types of apps in different ways. How can we capture all of those things? The only thing we can do is run experiments in a large scale so that it captures all the different combination scenarios we can possibly have in the world, and randomly split them into control and treatment group so that all the other noises can be canceled out, and we can be able to just capture the differences, the causal impact of the feature change itself. Second reason why we need to run experiments in the operating system is to be able to isolate impact with concurrent changes. You know, in operating system, the code base is huge, and they constantly have all different types of changes. And it's very difficult for us to isolate effects of a single feature. For example, we had this feature called Background Activity Moderator. The goal of it is to minimize the power consumption while maximizing responsiveness via throttling background processes. It means if the user has some YouTube video watching activity in the foreground, we would want to throttle the background activities so that we can maximize the user's experience. However, we know that this feature is trying to improve the battery life. And at the same time, there are probably 100 other features that are also trying to improve battery life for the device. How can we know if this feature is making battery life any better? Let's say at the end of the day, when we see for a device, the battery life becomes 10% better. Can we say that this feature itself is making it 5% better? Or is this feature making it actually 2% worse? How can we do that? How can we isolate the impact of just this feature on its impact on battery life? The answer is through experimentation. Due to randomization, all the other features impact are canceled out between control and treatment group. And the only difference is this feature itself. And therefore, any difference we can observe on the battery life metrics is due to this feature. The third reason why we need to run experiments in the operating system is to assessing trade-offs. So there are features that entail trade-offs between desired attributes. We need to be able to quantify and compare effects among multiple aspects. So we had this feature called low extra delay background transport. The goal of this feature is to improve users' networking experience by throttling background networking when there's foreground activity going on. It could lose, and at this point, the background throttling that we're doing is on the Windows error reporting. So of course, it could cause the loss of debugging data, impacting the quality improvement processes. So let's say your device is having some crashing issues, but we're delaying sending those debugging data back to Microsoft. So that would in turn delay us being able to debug the issue and fix it, and therefore it might affect a broader population. So how should we make that trade-off? How can we quantify the trade-off? The idea is through experimentation. Between control and treatment, we can see what's the improvement in the networking experience and how much of the debugging data failed to be sent to us in time. And with that quantifiable data, we're able to make the decision. The fourth reason why we need to run experiments on the operating system is to be able to limit the impact of failures. You know, for online services, they can be reverted quickly and effectively. For the OS, impacts of failures can be high, and updating the code is difficult and costly. Experimentation enables us to be able to manage the exposure on the cloud. An example here is the TCP fast open. The goal of the feature is again to improve users' networking experience, and it does that by reducing the time for network connections using a new cookie. It basically reduces the number of handshakes needed from 3 to 2. When we run this experiment internally, everything went perfectly well. So we decided to roll it out to the whole world. However, as soon as we roll it out to the whole world, in places like India and China, there was significant issues. And it was because in those different regions, the protocol is different. The underlying infra is different. And therefore, there were situations that were not captured when we were doing experiments internally or in the United States. So using the experimentation platform, we were able to roll it back from those regions immediately and then make the fixes and then roll it out gradually to those regions, making sure everything works fine. So this way, we're able to protect our customers from suffering from a bad networking experience. And the fifth reason, of course, is for user-facing OS features. So we have some features in the operating system that are actually user-facing. For example, the start menu is a good example of it. If you're a Windows user, you will be seeing the start menu all the time. And in one of the example, we were trying to remove the app listing setting, thinking it will improve the click-through rate on the tiles on the right. So the quantitative metric we had was the click-through rate for all the tiles on the right. And as we were running the experiment, we saw very positive movements on those metrics. So all the click-through rates on the tiles went straight up. And we thought it was a great experiment, it was a great feature, and we should just go ahead and ship the feature. However, once we look at the user feedback rating, turns out that we're having some regress in the user's rating. So we wonder, why is that? And then we went into the feedback that users submit to us through different channels. And it turns out that users are very confused when their app list setting is gone. They were trying to find what they're looking for. They couldn't find it, and therefore they just keep clicking on the tiles on the right, hoping that one of them will trigger what they were looking for. So of course, all the click-through rate went up. But who would have guessed without seeing the real data, without running this experiment? Nobody. It was completely unanticipated. So this is another reason why we need to run an experiment. At the end of the day, we ended up shipping this feature, but we kept the default as a list visible. So hopefully at this point, you understand why we need to run experiments on the operating system. Let's look into some other examples. So I'm going to give 3 experiments that ran at Microsoft for real, and each one of them provides an interesting lesson. All of them had enough users for statistical validity. And for each of the experiment, we will tell you what is the overall evaluation criteria, which is the most important metric that will determine if this feature is a ship or a no ship. And let's see how many of them you can get right. So I would like to do this in an engagement format, but I know everyone's in front of a computer. So let's try to stand up and get some stretch, do some exercise before dinner time. So hopefully you can all stand up, and you'll be given 3 options, and you will answer by raising your left hand, right hand, or not raise any hand at all. And if you get it wrong, you can sit down. And if you get it right, you can keep standing until the very last question. I sort of want to see how many of us can remain standing up. Since there were 3 choices for each question, just by random guessing, about 4% of us will be able to get all of them right. So let's see how much better than random we can get. The first experiment is about Windows search box. The Windows search box is in the lower part of the taskbar for most of the Windows devices. So here are the 2 variants. The first one says search the web and Windows. The second one says type here to search. The overall evaluation criteria here is the user engagement. Which one can drive more searches? Now, please raise your left hand if you think the left version drives better engagement. Raise your right hand if you think the right one drives more engagement. And do not raise your hand if you think they're about the same. There's no statistically significant difference between these 2 in terms of user engagement. Okay, hopefully everyone has made up their mind yet. Now let's look at the result. If you didn't raise a hand, you're wrong. If you raise your left hand, you're wrong. If you raise your right hand, you're good. Lucky, or look at the bottom left search box because it's already shipped. Actually, we experimented way more than just this. We experimented 4 variants. And in terms of the order of the performance, the first one is type here to search, which is the winner. Second one is what can I help you find? Third one is ask me anything. And the fourth one is search the web and Windows, which performs the worst. This one little change by itself was worth several million of dollars per year. I know, it's pretty crazy. The second example is about the search engine results page, which is the page you see on the right. Like you would type something in the search engine box and it shows you the results. The OEC here is the click-through rate on the very first result per query. So you don't need to worry about things on page 2, what's the click and back, like all those things. Like it's a very clear metric, the click-through rate on the first result in each page. The version A of it will show 10 different results. And in version B, we will show 8 results by removing the last 2 results. So the first 8 remain the same. And everything else is the same, like we don't change anything else on the page. We do notice that version B is slightly faster just because you're showing less results, but overall all the other things are the same. So now think about it. Which of the 2 designs, 10 results or 8 results, do you think drive more click-through rate on the very first results on each page? Raise your left hand if you think A wins. Raise your right hand if you think B wins. And don't raise your hand if you think they're about the same. No statistically significant difference. All right, hopefully everyone has made their mind. So if you raised any hand, please sit down. There is no difference between these 2 designs. In fact, the EXP team actually wrote a paper with several rules of thumb. And one of them is that reducing abandonment, the first click-through rate is hard. Shifting clicks is easy. There are a lot of interesting findings through all the experiments that we've run with the Bing team in the past. And of course, while there are obviously exceptions, most of the time users click at the same rate. The third example here is the Bing ads with site links. And the question we want to answer is that, should Bing add site links to ads, which allow advertisers to offer several destinations on ads? So the one you see on the left is the control group, and the one you see on the right is the treatment group. You see that there were the small, like ghetto code, find discounts, those small destinations on the bottom of this real estate. And the OEC here is the revenue. It's as constraints to same vertical pixels on average. The pro of adding it is that it becomes a richer ads. Users are better informed where they're landing. The cons is that the constraint means on average 4 ads versus 4A ads versus 3B ads. And also variant B becomes slower. So now think about it. Which of these two designs do you think can drive higher revenue? Raise your hand if you think the left version drives more revenue. Raise your right hand if you think the right version wins. Don't raise your hand if you think they're about the same. No statistic difference. All right, hopefully everyone's made up the mind yet. Let's look at the results. If you raised your left hand, you're wrong. If you did not raise a hand, you're wrong. Actually, the right one wins. So site link generates incremental revenue on the order of tens of millions of dollars annually for Bing. What does all these things tell us? Stop debating. Let's get the data. Let's run the experiments, get the data, and we know what our customers like. Here are some examples of a bad OEC. Let's go through a case study. For example, we know that moving the bottom middle call to action to the left can raise its click-through by 109%. So you see at the bottom of this chart, if you move it from the call to action from the very middle pane to the very left pane, just by that one small movement, you can improve it by 109%. So here comes the first pitfall, fail to agree on a good OEC. So usually when we work with teams to run experiments, the biggest issues with teams is that to start an experiment is to make sure that they can agree on what they want to optimize for, and also agree on the measurable short-term metrics that predict the long-term value, and also need to be hard to game. So in the Bing example, the Bing optimizes for long-term query share and long-term revenue. Short-term is easy to make money by showing more ads, but we know it increases abandonment. Our customers will be pissed off and they will just churn. They won't use Bing anymore. So revenue is a constrained optimization problem. Given an agreed average pixels per query, we need to optimize for revenue. The queries per user, however, may seem to be a good metric, but degrading results will cause users to search more. The sessions per user is a much better metric. Bing modifies its OEC every year as we understand as our understanding of the users improves. We still don't have a great way to measure instant answers where users don't click. So in this case study, why is this not a good OEC? It's because it's a local metric and trivial to move by cannibalizing other links. The problem is that next week, the team responsible for the bottom right call to action will move it all the way to the left and report a 150% increase. And then whoever is not on the very left pane will ask you to move their call to action part to the very left. And then they will start debating against each other. The OEC could be it needs to be a very global thing to page and use consistently. So something like the click-through times the value per user. The second pitfall through our experimentation is fail to validate the experimentation system. It's always easy for us to take things for granted, especially when there is already a platform well established we tend to believe that whatever they provide to us is already legit, and we tend to just trust whatever we get from them. However, as it turns out, getting numbers is easy. Getting the numbers you can trust is actually hard. For example, in the A/B testing world, we know there are some very famous books. And even for them, there were some of them get the statistics wrong. If you look at their Amazon reviews, Ronnie Kohavi, who used to be the experimentation lead at Microsoft, and now he works at Airbnb, he has some comments there saying how their stats were wrong. So usually, what would we recommend to teams to make sure that they can trust the experimentation platform that we built for them is run an AA test. So if the system is operating correctly, the system should find the statistic difference only about 5% of the time. And that is the p-value threshold that we give, 0.05. And an AA test basically means there is no difference between the experience that the users in the control group gets versus the experience that the users in the treatment group gets. So everything is equal, and we're literally just testing the system. Also, you can do a sample ratio mismatch test. For example, you can design costs for equal percentage to control treatment. And if you get different numbers as you expected, that means there's some sample ratio mismatch happening. And then you can go deeper and debug what is going on. SRMs is very critical because when SRMs happen, basically your experiment becomes invalid. You can no longer draw any causation from the experimentation results because at the very first step, the randomization, which I said is the very key step for experimentation, is no longer valid. And that just breaks the whole causation thing, and you can no longer draw causation. It is very bad and takes time to investigate. Here's an MSN experiment on adding more info pane slides. So the info pane is the hero image at MSN, and it auto-rotates between slides with menu option. So you see on the left in the control group, you see 12 slides. And on the right in the treatment group, you see 16 slides. As a result of the experiment, control group was much better than treatment for engagement, click-throughs, and page views. This was sort of surprising. We were expecting the one with 16 slides to drive better engagement. So what happened here? We looked into the data and identified some SRM issue. The SRM was actually very small. So in treatment group, we had only 49.8% instead of the 50% that was supposed to be. So what happened here? We then dug deeper and trying to see what is happening. Can you think of a reason? It is actually because user engagement increased so much for many users that the heaviest users were actually being classified as bots, and then they got removed from the data. And therefore, we had 0.2% less users in the treatment group. After fixing that issue in the data, meaning we're no longer removing those users as bots, the SRM went away, and at the same time, the treatment became much better than the control group. So you see tiny little things make a difference. So as data scientists who either you work on experimentation or you work on other domains in data science, we got to admit that the best data scientists are skeptics. The most common bias is to accept good results and investigate only the bad results. When something is too good to be true, remember this law. Any figure that looks interesting or different is usually wrong. Don't get so excited when you get some really, really good results. In fact, in the book Exploring Data, an Introduction to Data Analysis for Social Scientists, the authors wrote that Tolman's law is perhaps the most important single law in the whole of data analysis. Let's keep that in mind. If there's one thing you take away from today's talk, any figure that looks interesting or different is usually wrong. And again, the culture challenge is also hard. It is difficult to get someone to understand something when his salary depends upon his not understanding it. It is sad, but it's true. So why do people or organizations avoid controlled experiments? There are many different reasons. Some believe it threatens their job as decision makers. At Microsoft, program managers select the next sets of features to develop proposing several alternatives and admitting that you don't know which is the best sometimes could be hard. We also have editors and designers whose job is to find the best design. Failures of ideas may hurt image or professional standing. It's always easier to declare success when the feature launches. We have always heard people say that we know what to do, it's in our DNA, we've been doing this for decades, or why don't we just do the right thing? But what is the right thing? Do I have data to back it up? You'll recall for the culture change, which is called the HIPPO. HIPPO stands for highest paid person's opinion. So usually when you are having a meeting in a room, the one whose highest level is the hippo in the room. And in fact, hippos kill more humans than any other non-human mammal. Can you believe that? They look so cute. So yeah, we always need to listen to our customers and don't let the hippo kill good ideas. In summary, A/B test is the best scientific way to establish causation. It's hard to assess the value of ideas. We need to listen to our customers, get the data from them, do the right analysis. Also need to prepare to be humbled. Data trumps intuition, and we always need to drive for culture changes, for a more data-driven and more humbled culture. And at the same time, we always need to think about the OEC, make sure that the work agrees what to optimize for. It is hard because it seems like a lot of the things are all important to be measured. And what is that only thing that you want to optimize for? It is hard, but it's a good question to think. And also, you always need to validate your system and compute the stats very carefully. You need to make sure that you get a number that you can trust. Do the due diligence. And you can go to this EXP platform website to seek for all the papers that Microsoft has published in the experimentation domain. And I think to end this talk, I want to quote someone's saying on, if we have data, let's go with data. But if all we have are opinions, let's go with mine. Okay, with that, thank you very much for coming to today's talk. Do we have any questions?
Mary, I think we have one question.
Yeah, I see there's a question on good data collection. So yes, data for Microsoft Teams. The program is, yeah, I hear you. I personally don't work very much with the Microsoft Teams team, but I know that they're monitoring very closely on the feedback from our customers. There are multiple channels that you can submit your feedback, either through Microsoft Teams or through like Feedback Hub, or like even you're just doing it on Twitter and doing it at Microsoft. Like they're carefully listening to our customers' feedback, doing topic modeling on them, trying to understand what our customers are complaining for, and making the bug fixes all the time. Yeah, the Teams team is working on a very fast-paced. Hopefully, the product will become better and better in a shorter time manner. There any other questions?
Not now, but can I please say something?
Yes, go ahead. Thank you. Thank you, everyone.
So first, thank you all for joining us, and thank you, Mary, again for putting together such a great workshop. If you're not part of the Reactor community already, please do consider joining us on Meetup or directly through our Microsoft page. You can also follow up on Twitter or check our previously recorded workshops on YouTube. I have put the link where you can check this workshop, or as I mentioned, previously recorded workshops. And one more thing, if you have any feedback at all about how the event went, we would love to hear what you have to say through the link that I've also put now in the chat. And please use the code 12304. Thank you so much. And again, if you have any questions, please ask away. Mary, you got a question as well.
How many experiments are running for Windows these days? Does one A/B test correspond to one new flight? Not necessarily. Usually one flight would have a lot of different new features in it, and it might contain multiple different experiments. And regarding how many tests we're running for Windows these days, we're primarily running on Windows Insider population, which are on the users who have given us the authority to run experiments for them, who are enthusiastic about getting the latest and greatest features on Windows and helping us get feedback on them. So usually we only run on those devices, and that's about a couple hundred for half a year.
All right, everyone, since we don't have any more questions, we're gonna wrap up this event. Again, thanks a lot for joining us, and see you soon. Have a good one.
Thank you, everyone. Bye.